So welcome everyone, and today we are on the workshop 2 of this cloud computing workshop series. So we are going to focus on three things today mainly. IAM, that is Identity and Access Management, cloud networks and databases. So do you guys have any questions from last week? Anything related to the multi-factor authentication or the IAM user creation or root user creation? Okay, so let's see what content we are going to cover today. So if you have not set up the multi-factor authentication yet, please go ahead and do that for both your root user and IAM user. So, and for this workshop today, we want to have MySQL Workbench installed. So if you don't have MySQL Workbench installed on your machines, please go ahead and do that too. And remember the root password that you give when you install the Workbench. That would be needed when we at the latter part of our workshop today. And I'm trying to finish today around 12:45 or 1:45 Eastern. So let's get started and get going. So IAM, it's a service in the AWS console, and many cloud providers have this service mainly for identity and access management. So what it does is it handles user creation, how you combine multiple users into groups, how you assign them permissions, how you provide them passwords and other access keys to the cloud services. So all those things are handled by this identity and access management service. So generally, when you consider AWS, there are three ways where you usually access AWS services. One, through the console, that is where you enter your username and password and you select the service that you want and then do whatever the instance creation, network creation, user creation, and everything. That's the console access. Then you have something called the CLI, command line interface, where you can write commands in the terminal, either in the Linux terminal or using the Windows PowerShell to do anything in the cloud. So, for instance, here I have shown how you can create a S3 bucket or an object. S3 is an object storage service in the AWS. So if you want to create a bucket to store your images, files, or anything, this is how you can run the command to create a bucket. And similarly, you can use any programming language of your choice to communicate with the cloud using its own SDK. So on the right hand side, I have shown you how you can use some Python code, Python AWS SDK to create a bucket. So even though it's multiple lines, like if you are good with Python, it's easy to follow. You have to provide the bucket name, the region, and any special access configuration for the bucket. So these are the three main ways that you can access cloud services. So additionally, if you like, there are certain limitations, like some of the uh, actions that you do in the CLI are not permitted through the console. So there are certain limitations in each of these method, but mostly they share the common access. Like most of the actions can be done in either of these ways, but there are specifically they specify this command can be executed only with the CLI likewise. So there are very tiny limitations, but overall they share same actions, same permissions. So if you want to use CLI, there is a AWS CLI you need to download, like a software, scripting software, then you need to create something called uh, access key and a secret key. You have to provide that every time you run a command like this AWS S3 make bucket, all those CLI commands. You will have to have that initial setup ready in order to execute the commands like this. So we will do some of those in our future workshops, but today we'll be mainly working in the console, creating networks, creating users, and then creating the database. So some entities in this IAM console are the users like the IAM user that you created last week. Then sometimes we have something called roles. Roles are really important where you don't have to share your credentials, which is a risk when you share credentials like username, passwords. It's a risk of there is a risk that they can be compromised. But if you use roles properly, you can get rid of that risk, and it's a safer way to access the cloud. Then policies are basically the permissions that you assign to a user or to a role. Then groups are like a combination of users mainly. If you want to give a set of permissions, not just to a single individual user, but to several users, you can create a group and put all those users into a single group. So in that way, you can easily attach permissions to the entire group or remove certain permissions from the entire group at once rather than assigning permissions and removing permissions from each individual user. So let's check something out on the IAM console. So what I want you to do, I want you to open a new Chrome window. Uh, in the show for a second and uh, get to the console with the root user. So I'll go to the AWS console from here. So what I want you to do is first create a user with first login using the root user. So I'm going to use my root user email and then password. And then I want to create another like login using the IAM user in a incognito window. Because I want to show you how the permission how you can attach or detach permissions from each user. How it's going to impact. Okay. So I had already look when I can get out and show you again. So my account number is this one. So if we go to root user count and check my current user permission. Now IAM is this service where you can view all these users. So you need to go to the IAM console. So you go here and then I check the users here. So this is my IAM user. And if I go to permissions, I have two permissions attached to this user, administrate access and IAM user change password. So if you remember last time, we had an issue when we were trying to enable MFA for this IAM user. We had all these red boxes saying you are not allowed to do, you are not allowed to do like that because we initially had attached only this permission, IAM user change password. That is why we were able to change our password in the first login, but we could not enable MFA because we did not attach that permission here. But instead, what we did, we enable the administrator access. So this gives you like whole lot of access to the console. But there are certain limitations in the administrator access as well. It does not let you view the billing dashboard. Now, if I go here and if I try to view the billing dashboard, it will not, it says you need permission. So IAM users, even though they have the administrator access, they are not provided the billing. They are not given access to the billing dashboard. If you need that, you have to grant special permission from this console here. But what I'm going to do now is uh, I'm going to remove this administrator access permission from this IAM user. I'm going to see what's the impact on this IAM user. Now let's go to the IAM console. Okay, now I have all these green tick marks, everything here. So I'm going to remove this administrator access and see how it's going to affect this other account. So the permission is removed. Let's refresh the screen and see. So you see here, all those things, even the MFA access, I cannot see anything here because I removed the administrator access. Only thing I can do is I may be able to change my password. That's the only thing I can do here. But that also may be only on the first attempt. Now let's do something here. Now I'm going to see, I'm going to uh, move to my S3 console. It's the object storage service. So I go there and try to see if I can do any bucket creation or list any buckets here. Let's see. I'm going to see the buckets. So it says you don't have permissions to list buckets. Now, instead of attaching the administrator access, I can attach service specific permissions. For instance, I want to give S3 full access. So what I'm going to do, add permissions here. I select attach permissions directly. And then I search here S3. So I select this one, Amazon S3 full access. So if I select this, I get all the S3 permissions like list bucket, create bucket, delete bucket, all those permissions I can assign to this IAM user. So I have added that permission here. Now you can see S3 full access I have added. And now if I refresh this page, I should be able to see the bucket. There are no buckets set, but that error message, access denied error message is gone. And if I want to, I can create a bucket also. So likewise, you can have that service specific for any service. You can have full access, or if you want read only, there will be a read only permission as well. Let's see. Let's assume RDS or maybe DynamoDB. DynamoDB is a like key value storage in the AWS. So I can give full access or read only access. So I give this user S3 full access, but I give only DynamoDB read only access. So likewise, now if I go to DynamoDB, since I don't have any tables here, I don't think I can show you anything, but try to create. Let's assume I'm trying to create something here. I'm getting I cannot redo any creations. I can do only the read access only. So that's how you can control users access or group access or roles access with this IAM console. So that is the first thing that I wanted to show you guys today. So let's get back to the presentations and continue. Okay. Today the next part we are going to consider is the cloud networks. Currently, AWS is spread across so many regions in the world. So when I did the first workshop in like 2 years ago, they had around 25 regions. Now for the past maybe 2 years, they have expanded up to 31 regions. And by that time, they had around 80 availability zones. Now they have 99 availability zones. And earlier they had around 218 edge locations. Now it's over 400. So what are these regions, availability zones, and edge locations? We will go a little, I'll give a brief introduction on them. So region is kind of the main geographical location for the network. For instance, US East 1 is a region, US East 2 is a region. For instance, US East 1 is located in the North Virginia region. US East 2 is located in the Ohio region. Then you have US West 1, West 2, likewise located in the West Coast area. So how they are connected, like how the availability zones and regions are connected, is that every region has at least two or more availability zones because of availability issues or yeah, mainly for the availability of the systems, because all these are systems, infrastructure, and physical things that can break for whatever the reason. For instance, let's assume you have two available. Now, the US East 1 region has around 6 availability zones. So if there is an issue in one of the availability zones, it's easy to move that infrastructure from maybe US East 1A availability zone to US East 1B availability zone. And that is how their infrastructure is considered. If you specify uh, something called multi-AC replication, so that you allow AWS to replicate your infrastructure in multi-availability zones. So then if there is a failure in your RDS in one availability zone, they will easily spin up a similar instance in another availability zone. So likewise, for service resilience and service availability, that is how these availability zones are contributing. And this edge location, they have their own specific purpose. They are like cache locations. Like imagine a situation where you are watching a video from an Asian country, and your video is located somewhere in the US West Coast, one of the AWS servers in the US West Coast. So if you are watching that video from Asian country, you will have to come through the entire network, entire AWS network, every time you want to watch that. But that will cost a lot of network bandwidth, and it's unnecessary. If that video is watched by many other Asian countries or many other viewers in Asian countries, it is always like waste of resources when for every request when if you have to access that US West server. So in order to avoid that unnecessary network waste or network resource waste, I would say, they have these edge locations where they have cached commonly accessed resources closer to the users. So assume you have like 10,000 users accessing the same video. So that video will be cached in an edge location closer to the Asian region. So it will be easy. So that entire always you won't need to consume the entire network to reach from Asia to the West Coast. So likewise, edge locations have their own purpose, mainly for caching, but now they have developed and improved their services. Sometimes certain computing processing can also happen in this edge location in addition to the caching purposes. So those are the three main ways how they contribute to the network. And let's move to the next one. So when you consider about cloud networks, we usually even in a data center, if even in a data center, we usually before we set up a server or before we host an application, we initially need to have a network, right? We wire the computer servers, and then we specify IP addresses and everything. We may have a switch, router, and all those devices set up. So similarly, in the cloud environment also, you need to have a basic network. So that is what we called as a VPC or virtual private cloud. So in the AWS world, this VPC is like the basic building element. Everything is built on top of the VPC. Like then first you create the VPC and then you divide divide that network into subnets, into smaller networks called subnets. So they can be either private subnets or public subnets. We will go into those details soon. And you can have in the VPC, you can have what you call an internet gateway, that is a router to the to reach internet. And then you will have something called a NAT gateway, a network address translation gateway, that helps uh, your private the instances in your private network to reach the internet. So likewise, the entire infrastructure is built upon the VPC and the subnets that are associated with it. So one thing, so the difference between a private and a public subnet is, if it is a public subnet, it has uh, a point to the public internet, like point in the sense, if you are familiar with something called route tables, the public subnet will have a route to the internet. But in a private subnet, you don't get that route to the internet. So those instances in the private subnets, they are much protected compared to those instances in the public subnet. So this is a common question, like you should have thought, or you should need to know, like what sort of service, what components of a system would you place in the private subnet and a public subnet. Let's I would give some hints to you, and some of you may answer that. Can answer unmuting yourself. So in a private subnet, you need to have more protection. You that has to be like any public or internet access should be prevented. And then in the public subnet, you allow certain IP addresses, certain networks to access the instances in the public subnet. So what sort of components would you place in a private subnet in a network? Any any guesses? Yeah, no worries. You are here to learn, so we can go ahead. So usually database is something really important that we want to block from internet. So that a database is usually placed in a private subnet. That is one thing. And then your web servers, your application, the servers that are running your application, they are also usually hosted in the private subnet. So what do you place in a public subnet? Mainly, uh, you now you will learn about a component called load balancer that routes traffic uh, from the internet to divide or distribute the traffic from the internet to your web servers. So that load balancer should ideally be placed in a public subnet, because all the entire internet should be able to access the load balancer. Then we use something called a bastion host, or sometimes it is called as a jump box. Uh, Now, since the database is going to be in the private subnet, we should have some way to access it from the outside internet. So the only way that we allow for the database access is through this bastion or the jump box. So this bastion or the jump box is also placed in the public subnet. So from our home, we can connect to the bastion first, then we connect to the database in the private subnet. And this bastion access is very much limited to maybe my own IP or just my Office VPN. So anybody outside the Office VPN cannot access the bastion and hence cannot access the database. So that is how we can place certain servers or databases in either the private or the public subnet. Then this security groups is a kind of a firewall in the cloud world. So it specifies whether certain instance can be accessed on certain protocols, certain ports, and if you want to restrict access only to certain IP addresses, only to certain networks, likewise, you can control it through the security groups as a firewall. Then the CyberBlock blocks is another way you can specify networks. Like earlier we used to use specify a network using IP address and what you call subnet mask, but now the trend is to use CyberBlocks blocks. So CyberBlock block is like it's a normal IP address followed by a suffix. So let me show you how you can understand CyberBlocks blocks. There is this website called Nginx Toolbox. Yeah. So what I mentioned you, like it's a regular like IP address. So I can specify something like this. A regular IP address is like this. There are like 4 components, each with 8 bits, 8-bit number. So then this is the suffix that I was pointing to. So if it is /32, that means there is only one IP address. So it says IP is in range 1. So if I put here 31, so it's like a 2 to the power scale. So if I put 31, you get 2 IP addresses. And so these are this is the IP address range that you are allowed to. So how I have understood this. Let's go to another one, 3. So it allows this much of IP addresses from 10.0.0.0 to 10.0.0.3. So it allows the entire range 10.0.0.1, 10.0.0.2, likewise until up to 10.0.0.3. If I go to like here, I get like 8 possible IP addresses. Then here 16. So likewise, the lower the suffix, higher the range of IP addresses that are available to you. So you can see here how many IP addresses are possible with each of the suffix. And then, so that basically means like this 28 means there are like from the 32, like 4 bits are variable. 4 bits can vary. So 4 bits can vary means it's 2 to the power 4. That is how you get the 16 IP addresses. So if you move to 27, it's 32 minus 27 means 5. So the last 5 bits can be varied to generate an IP address for this range. That is how I have understood it. You will have your own way of remembering it, but this is the basic understanding you need with regard to CyberBlocks. Any questions on that? Yeah, should be good. The next thing we want to learn is the internet gateway. Like it is how you route traffic to the internet from your subnets, and only the internet gateway can access the internet for your instances. Your instances cannot directly access the internet without the internet gateway. Then, if there are any instances in your public subnet, they do what we call the network address translation. So that is how the instances in the internet know the IP address if they want to reach one of your public instances. Let's get to them. These are a little technical, but we will do things practically to understand how each of these components work. So what I want to do, yeah. So let's get started with the VPC creation. That is the main network creation. So, and then we will go on to create the firewalls, and then the database and the bastion, all those components we'll create. So this is the root account. So I'm going to use the IAM account, but I want to attach the administrator access first, make things smoother. So I'm going to attach administrator access to this IAM user. And I can get rid of the S3 and DynamoDB because when I have administrator access, they don't make sense. Okay, right. So I'm going to do first, I'm going to go to my VPC, that is like the network service in the console. I go there and I create the first VPC. And there are limitations in accounts also, like there are like 10 VPCs, or like I think there are 10 VPCs that are allowed in a single basic account. If you go for a business account, you can have more than that, but there are certain limitations in these services also. What I'm going to do, I'm going to say create VPC, and here you can have either just create the VPC, or they give they allow us to create all the VPC, and inside them private and public subnets, all those things they allow. So I'm going to use that feature because it automatically creates everything for me. So now, so I'm going to use this CIDR range. So my entire network has this many IP addresses, 65,000 IP addresses, but then I want to have like 2 availability zones in case one of my availability zones fail. I have availability in another availability zone, and then number of public subnets. So if one of the subnets are basically created in one availability zone. So if my public subnet in one availability zone is failed, I have it available in another. So similarly for the private also. So I create public subnets in 2 availability zones and private subnets in 2 availability zones. Then CIDR blocks, like so each small network has its own CIDR block. So out of that 65,000 IP addresses, I'm specifying 4,000 for my USDs to 1A public subnet, USDs 1B public subnet, this many IP addresses. Then USDs 1A private subnet, this many. So likewise, I still have around maybe 40,000 IP addresses left if I want to create new subnets in the future. Then I don't specify any NAT gateway here because there will be a charge for that. And then endpoint, this is if you want to create an S3 bucket and you want to create to the bucket through the AWS network. without using the internet. You can have that S3 gateway, but we are not going to do that today. So I'm going to skip that. And this enable DNS hostname and enable DNS resolution, these both should be ticked because so that you can reach your bastion that is in the public subnet. It will get a public IP address you can reach from the internet, but instead you can specify a user-friendly DNS name uh, for that. So for that to work, you need to have this enable DNS resolution and enable DNS host names available. So the rest of the things are default, and tenancy should be default. If you use dedicated, it will incur cost. So default means your VPC, the network, it's like on the same network with it's shared with other, like it's the infrastructure network is shared with others. That doesn't mean they can reach your network, but the hardware is shared with other cloud users, but your network will have its own private access. So I create the access, create the VPC, so all those things get created. Now we'll go to the route table to see what I meant by this internet gateway. So I go to route tables and I go to the public public route table first, and I show you here. So this 000 means the entire internet is referred by this CIDR block. So if there is a request to the internet, it's going through the tag. IGW means the internet gateway. So it goes to the internet gateway. That is why we need an internet gateway for the bastion to connect and request to come to that request to come from the internet to the public subnet. We need to have the internet gateway. Uh, so that is one thing I wanted to show you. And so this is the entire VPC side. So if there is any request to this, any IP address in this range, it says it's local. So it is resolved locally without going to the internet gateway or any outside resources. Let's have a look at the any of the private routes. So it doesn't have a route to the internet. That is why they are called private. And so if there is any IP address that is inside this range, its target is local, so it will resolve inside the network without going outside the network. So that's basically the route tables, and you can see here the subnets that have been created. So now I did some creation, subnet creation earlier, so you should have these 4 subnets created. You can see here, public 2, public 1, private 2, private 1. We created 2 subnets for in each private and public. So they are here, and the IP addresses are also here. Likewise. So that's basically the VPC and subnet creation. Now we want to set up the firewalls. So to do that, I can just search firewall, not the security groups. So security groups is actually in the EC2 console. So when I type security group, I get I go to features and say EC2 feature, or if I want, I can go directly to the EC2 console. I go to EC2 console, and then I set up the security groups. So I created my VPC as project. So I'm going to use the same notation for the security groups also. So we need to have 2 firewalls, one for the Bastion and one for the database. So Bastion should allow my IP, my public IP on port 22 to do the SSH connection, to create the SSH connection. And the database should allow the Bastion to connect on the MySQL port 3306. So I'm going to create a security group. I'm going to use this VPC name project, then Bastion security group. I use the same name as the description for the description too. So the VPC, I select the project VPC, then I add the rules. So what I want SSH. Now here you can specify custom IP address or your IP address. Now, when I say my IP here, I'm connected to my office network, so it is always this IP address I'm getting. So, but if you are not connected to any VPN, this will change every time you connect to internet. Your public IP will change. So, if in order to have consistent access, I advise you to connect to maybe your University of Iowa VPN and then get that public IP and put it here. So every time when you are connected to the VPN, you can access the Bastion. Otherwise, you'll have to allow the entire internet to access the Bastion via the SSH, which is not very good, safe. So I allow this my IP address to access the Bastion, and then I say, okay, so outbound rule means all the traffic to the internet should be allowed. So we can control outbound traffic too, but in security groups, what matters mostly is the inbound. So we have to allow the inbound. Then anything goes outside, we can always allow all traffic to the internet. 000/0 means the entire internet. So I create the security group for the Bastion. Then I'm going to create another security group for the database. Security groups are here. Create another security group. So I'm going to use the same VPC name project DB security group and copy that one here. I'm going to use the project VPC and inbound rule. Now I want MySQL port. So MySQL Aurora you can put, and then here you specify custom, but here you can specify the subnet. If you want, you can specify both the public subnet, like here. You can get their CIDR ranges and assign them here, or subnets. Or you can specify a security group now. That when we create the Bastion instance, it will get its security group, the one that we created earlier. So you can specify that Bastion security group here. So every time a Bastion instance created, it gets this security group. So you allow this security group on port 3306 to the database. So all those instances that have this Bastion security group will have access to the database. So I'm creating the firewall for the database similar to this, and you allow all traffic to the internet again and create the security group. Now both our firewalls are ready, and we are going to create the Bastion now. So to do that, I have to go to the EC2 instances page, and I'm going to launch instance. I put here project Bastion, and then like there are, you can start a Linux instance if you want. You can start a Windows instance, Red Hat, anything, even Ubuntu. But I use the Amazon Linux, that is the Amazon's form of Linux. I use this AMI, means the image, like the latest images. They say this is free tier eligible, so we don't want to incur any expense, so use the FATI eligible AMIs. And so T2 micro instance type. So if you want to now, Bastion is not going to be handling a lot of traffic. And if you want to have an instance that handle a lot of traffic like a web server, you will need to go for a bigger instance size. But for the Bastion, we can just do with a T2 micro, the smaller instance size. So this architecture and all, you can leave them as default 64-bit. And to connect to a Bastion, you need to have something called a SSH key or a PEM file. So I'm going to create that also. I provide a name project. So we usually use this RA, RSA, or you can select anything, but I prefer to use the RA. So the private key format, I want to use the PEM format. That is for SSH. But if you are using Windows, you might need to use the PuTTY client. So in that case, you will need this .ppk format to connect to the Linux instance. I say create key pair, and it's going to ask me where you want to save that PEM file. So I say save that in my downloads project bastion.pem, save it. Right. And then I need to set up network for this instance. So what they usually select is this default VPC that is also originally created, but we have to select our custom project VPC. And then subnet. So it's a private subnet they have selected, but I want to have the public subnet selected. I want the Bastion to be in the public subnet. I can select either of them, but I select the public one. And auto assign public IP, I put that as enable because I want to be able to connect to that from the internet with a public IP address. Then security group, that is the firewall. I say select existing security group and select the project Bastion security group. Okay, and if you want, I can assign the database one too, but we will use that for the database specifically. So number of instances, one. So if I want to attach a storage, I can do that too, but for the time being, we will create the instance here. Okay. Now the instance will get created, and I will show you how we can connect to the Bastion from my local machine. So to connect to that, you need to have the instances private public IP address. So usually Amazon Linux instances, they have this EC2 user as the normal user. So I'm going to get this instances IP address, public IP address. And here, sorry, before that, I have to do something. I downloaded the PEM file, but it has more lenient permissions and I want to override them. So there is a command that you need to write, like I update the permissions of that file. Let's see, I'll just show you what permissions it has. Go to downloads. Check STM there. So you see here, it has, I don't know whether you're familiar with the Linux file permissions, but this is another 3 8-bit numbers are here. So read, write, root user has read, write. Then the EC2 user has read only, and user group has read permissions. But this is too much permission for this file. SSH doesn't allow this many permissions for a PEM file, so I have to update this. Okay, now let's see the permissions. So you see here, now the write permissions have gone from the root user, EC2 user, and I mean the user group, they don't have even the read permissions. So what I'm going to do now, I'm not sure whether the second one is EC2 user. Maybe it's the other way. This may be the EC2. This may be the root or the group. You can check that like with if you Google like Linux permissions, it's easy to find. So I have updated the permissions on the file, and now I should be able to SSH with the EC2 user at the IP address again, public IP address here, and then I specify the PEM file that I need to use to connect to this instance project. Okay. So it asks for this. It says there is no authenticity. Authenticity cannot be established. We are sure that this is something we want to connect. So I put yes. Now I'm in this server that is in the AWS cloud. So I can just view maybe if I want to move to the root user, I can put like this. So now I'm the root user. If I want to see any content in this EC2 user folder, you can use ls-la. If I want to go to the root folder, I can see that. Now I can see all the root folders in the root folder, like the main folder. All these files are accessible since I'm the root user. So all these things you can do if you want to host a web server, an application, you can do everything here. But we will work on that next week. And next I want to do is the database creation. So for that, I go to the RDS service, the AWS database service, and I'm simply going to create a database. I say standard create, and we have to use this MySQL engine because that's the only free tier that only provides free tier access. So I select free tier here, and I'll put the project on here, the same notation standard. So I use the admin username, master username will be admin, and here I specify a password. And instance I use this small database instance type db t3 micro. All these things I leave as default, but there is one thing I want to change here. Virtual I want to host this in the project VPC, and subnet groups are mainly if one of the subnets failed, you can spin up the same instance in another subnet. So that purpose, you can create a subnet group. So you don't want the RDS to have a public access, so you say no. And the security group, you have the existing one that we created for the database, project DB security group. You remove the default one. So only the project DB security group is attached to this instance. Availability zone, you don't specify. So if you put no here, it will be created in the private subnet. So we are good with that. Let's create the database. I think we are doing the rest of it. Oh, you have to provide the master username. Okay. Okay, so we'll wait a second until this database is created. We don't want these add-ons. We can stop that. So it's still being created. So until then, we can have our MySQL Workbench connection ready to access. So we still don't have an endpoint here. We'll get that soon. So since until then, we go to MySQL homepage and we try to connect to the database from the workbench. So you have to specify this TCP IP over SSH, and I want to do here. SSH hostname is your Bastion hostname. So Bastion IP address. To the EC2 console to get that. Got the public IP address. So EC2 user is my SSH username, and the key file is that PEM file that I downloaded, Project Bastion. Then this is the MySQL hostname. That is the endpoint that we are waiting to see here. Let's see, it should be ready now. A little fast behind my expected time, but we'll finish this and we'll set up the connection, and then we will continue the rest of the slides next week, hopefully. You have any questions so far? Feel free to ask. The endpoint should appear here when the status becomes available, so we are waiting. Databases take some time for the creation part. Maybe we can move to the slides and finish it soon. So security groups, they work like serve as firewall in cloud networks. Stateless means if the inbound is allowed, outbound is automatically allowed, but you can still have some control using something called network access control list. They are stateful, they maintain the state. Then we can restrict security firewalls using port numbers, side ranges, and we can specify other security groups, subnets, and everything in the security groups. So the security group for database, this is how we specified. We allowed port 3306. The internet side, if you want, you can specify 00, but this is for the maybe for the load balancer, you allow the entire internet to access. So you can specify the internet side there. So we did most of it now. We have done most of this now, DB creation part. And it's always the insecure implementation. If you specify the DB database in the public subnet, it's like insecure. Anyone from the internet can access it through port 3306. But the best implementation is you specify the Bastion in the public subnet, and only the Bastion or the web servers can access the database. So the Bastion is accessed on port 22 from the office network, and then Bastion can provide access to the database. That is the best way to access. So we have done this best practice implementation. We have created the Bastion security group, database security group, Bastion PEM file we created database. Now we are checking the connection. So that's all in the slides for today. And let's see if okay, we have got the endpoint. So I'm going to copy this endpoint and paste it in my workbench as the MySQL hostname 3306, and master username was admin, and I click on test connection and I give my password here. So it says successfully made the SQL connection. Okay, so I can specify that connection as project one and okay. Now I can easily access that database from here. And so I can see the schema. So it usually default comes with just one schema, the C schema. Maybe it has the no. We can create another schema here if we want, like the test schema, and then create our user tables, our application related tables, and everything here. So we'll do that next time. And this is all what I planned for today. You guys have any questions? Yeah, thanks for the clap and thanks. I mean, if you don't have any questions, I'll send you the recordings because some of you could not join today. So I'll share the recordings with you maybe today or tomorrow. And see you next week. Thanks everyone for joining.
Thank you.
Thank you.